Algebra 2, Unit 7, Trigonometry, the concept 33 notes, right triangle trigonometry. So start by getting down some vocabulary and definitions. You're going to need to pause the video so you can write the definitions down. Make special note of the trig functions, which you may remember from geometry, also the Pythagorean theorem, which you also may remember from geometry, and the special right triangles. A new concept that we're going to talk about are angles of elevation. Now let's start some notes. So look at the graphic here. We've got a table showing the 6 trig ratios in a right triangle. We've got the sine of theta, and that stands for an angle, is the side that's opposite across from the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So in a right triangle, one of the acute angles will be labeled, in this case, theta. And so if we have a right triangle like this, the sine of theta would be the ratio of the side that is opposite of theta. So you get right in the middle of the angle, you look directly across, so that would be 4 over the hypotenuse. And that is the side that is always across from the right angle. The adjacent side, for example in cosine, is the side that is just next to the angle that you're looking at. So in the example of this triangle, the adjacent side would be 3 because it is touching the angle but is not the hypotenuse, and then the hypotenuse is 5. So these angles change depending on, these sides change depending on where your angle is. So if we construct this triangle again, but this time we denote this angle as theta, then you can see that our sign will change because it will be opposite over hypotenuse, 3/5. There is an acronym that will help you remember these ratios, at least the main 3. And that is SOHCAHTOA. This is how I write it and how I suggest that you write it in your notes. So sine is opposite over hypotenuse, cosine is the adjacent side over hypotenuse, and tangent is the opposite over adjacent. So SOHCAHTOA. In the second row of the table, we have what we call the reciprocal functions. So look how these are just the flip of the ones below, the reciprocals. These words are cosecant, secant, and cotangent. And I've shown you the proper abbreviations in this table. Now look at example 1 with me. We are going to find the trig ratios given 2 sides of a triangle. So sine, cosine, tangent, and then cosecant, secant, and cotangent. So this is a right triangle. Remember the Pythagorean theorem. So you can use that to find the third length. I've done the work. So 5, 12, and then our third length would be 13, and I've gone ahead and labeled it. So now we're going to find the 6 trig ratio. So I put my eyes on theta, and for the sine, I'm going to look across, directly across, because this is the side that is opposite, and then I'll put that over the hypotenuse, which is 13. Now I'll put my eyes back on theta, and I need the cosine, so the side that is adjacent, which is touching the angle but not the hypotenuse, and then over the hypotenuse. And then finally the tangent, that is the side that is opposite, which we know is 12, over the side that is adjacent, which we know is 5. Now our lesser 3 trig functions are easy at this point. Cosecant is the reciprocal of sine, so we can just flip that sine ratio. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So we've done it. We have found the 6 trig ratios. We're going to use these later in problems to solve triangles. Look at example 2 with me. First of all, we're going to use the Pythagorean theorem to find the missing length of the right triangle, and then we're going to fill in all of the trig ratios. So notice we're told that the sine of an angle in a right triangle is 4/7. So construct a right triangle and label one of the acute angles theta. And then for the sine, we know that that is opposite over hypotenuse. So label your sides. 4 is the side that's opposite, and 7 is the hypotenuse. Now use the Pythagorean theorem to find the third side. This would be a leg, so we would need to set it up like I did there. And then we're going to leave an exact answer. So our third side will be the square root of 33. Now let's find those trig ratios. So we'll fill in what we know, and then we'll just go ahead and write the cosecant, because that will be the reciprocal. Now I'm going to look at my triangle for cosine. So the side that is adjacent to my angle is the square root of 33. And my hypotenuse is 7. So now I can write my secant. But we are not going to leave that square root in our denominator. So we're going to multiply top and bottom by that square root to rationalize. So we'll end up with 7 times the square root of 33 over 33. Now let's do the tangent. So the side that's opposite is 4 over the side that adjacent is the square root of 33. So again, I'm going to rationalize by multiplying top and bottom by this. So tangent is 4 times the square root of 33 over 33. And then for cotangent, I'm going to go back to my original and just take the reciprocal. So the square root of 33 over 4. And now I know the 6 trig functions of this right triangle. You might have learned in geometry about some special right triangles, ones that have a certain combination of angles, and so their side lengths are in certain proportion. So our 2 special right triangles are a right triangle whose angles are 30 degrees, 60 degrees, and 90 degrees. If you have a triangle such as this, then the ratio of the sides, starting with the one across from the smallest angle, is in a proportion of 1, and then the side that's across from 90 to the square root of 3. So one way to think of it is you can think of it as the side that's across from 30 as 1x, the side that's across from 90 as 2x, and the side that is across from 60 as x times the square root of 3. And then we can use those proportions to help us solve triangles, or solve for lengths in triangles under 30, 60, 90. The other special right triangle has the angles 45 degrees, 45 degrees, and 90 degrees. And those side lengths are in a proportion, starting with the legs that are across from 45 degrees. They are in a 1-to-1 ratio. And then the 90-degree side is 1 times the square root of 2. Or we can think of it as 1x to 1x, 2x times the square root of 2. So when you're working a problem like example 3, you notice you have a 30, 60, 90 triangle. We can just fill in that third angle. We know that the side across from 30 will be equivalent to 1, and then the side that is across from 90 will be equivalent to 2. So if we simply work backwards from that, we know that our 30-degree side has to be half of our 90-degree side, so it has to be 4. And now what we're looking for is the side that is across from 60 degrees. So the side across from 30 degrees is in 1 to 2, and then square root of 3. So I can simply take my 30-degree side, which is 4, and multiply it times the square root of 3. And I've got that missing length. Let's look at example 4. So now we're back just to a right triangle with some random angle measures. So I have one angle that is 28 degrees. Of course, I have my right angle 90. And so right away, let's just find that third angle. So subtract 28 from 90, or you can take 180 and subtract off 90 and then 28. And so we know that that third angle will be 62 degrees. We're going to use a trig ratio to find the missing length. So first we're going to find the length for A. So I look at what I know and what I want to know. I want to know side length A, and I know this side length of 15. I know this angle, 28 degrees. So I have this angle I want to know the side that is opposite, and I know the side that is adjacent. So I think about SOHCAHTOA, and the trig ratio that matches is tangent. So I can set up an equation using that trig ratio. So the tangent of 28 degrees will equal the side that's opposite over the side that's adjacent. And then I just do the steps that I need to do to solve for my variable. In this case, it's A. So now you're going to take your calculator and make sure that you are in degree mode. If you're not sure how to do that, ask a friend or one of the teachers right now. Then you'll take 15 times the tangent of 28. And then we'll go just to whole lengths, so round to ones place. So 7.97, that'll round to 8. So we have a length of 8. And now to find C, so I'm going to stick with the things that I was given. So I know 28, I know the side that is adjacent, and I want to know the side that is my hypotenuse. So adjacent and hypotenuse would be cosine. We could also use the Pythagorean theorem to find this side length as well. There's actually quite a few ways we could find it. So this is just the trig function that came to my mind. So first of all, I'm just going to multiply both sides by that side length. And then I'm going to take 15 and divide it by the cosine of 28. And so our side length is 17.